I'm Anil Kumar, and here is question number 26, page 84 from Nelson, chapter 2.2, derivatives. So we are learning how to apply power rule, and there we have this particular thinking question. It is indeed a very interesting question, and we'll take it up later also when we learn some other rules about finding derivatives. The question here is, let P AB be a point on the curve square root x plus square root y equals to 1. Show that the slope of the tangent at P is minus square root b over a. So let's first begin by saying what will the equation be if I substitute x and y as a and b. So this point is AB. So let me write x as a. Then I get square root of a plus square root of b equals to 1. So this is the relation I get by substituting this point in the equation. So that is also true. That's first part. We'll soon use it to derive the result. Now, to solve this question, we have an equation which has x and y terms combined. So let us isolate y first. So we can isolate y by saying y square root is equals to 1 minus square root of x, right? Now if I square this, I get y equals to 1 minus square root whole square. Correct? So that is how we can isolate y. And now we can find the derivative dy dx here. So some of you may write dy dx, right? So we write dy dx, or you could also use the nomenclature y dash, which means derivative with respect to x, right? So some of you could also write this as, which is same as y dash, right? So here we are doing derivative with respect to x. That is the independent variable, right? So let's apply the rule, which is the power rule combined with the derivative of inside function. So we get 2 times all this, which is 1 minus square root of x, to the power of 2 minus 1, which is 1. So I'm just writing 1, we should not be writing it, times the derivative of inside terms. So times, let me write d dx of minus square root x. Is that okay? So let's continue with this. So we get 2 times 1 minus square root of x. Now derivative of this is minus, right? It is, let me write here in brackets, minus 1 over 2 square root x, correct? Okay, so if I simplify this, 2 and 2 will get cancelled. So I get, and we have a minus sign here, so we get minus 1 minus square root x divided by square root x. This is what we get. Let me write brackets here. So this is what you get as the derivative. Now derivative indicates the slope, correct? Derivative indicates the slope. So we can say slope of the tangent line at P should be what? If I substitute, so we say slope of the tangent line here, let's say slope of tangent line at P. The point is AB, so x values A, y values B is what? So this is the slope at any general point on the curve, correct? So we can substitute x with A. So if I do that, what do I get? So we get slope, we can write y dash, or you may write slope, whatever, and substitute. So let me write at x equals to A, okay? So x values A for me. So I'm replacing with A, so I get minus 1 minus square root of A over square root of A, correct? That is it. Now, what is 1 minus square root of A? So if I rearrange the initial equation which I had, what do I get? So let me rearrange this and you'll see what it is. The square root of B is equals to 1 minus square root of A. You get the idea? So that is what we are going to replace now with, and we get that the slope of the tangent is equals to minus 1 minus A square root B, right? So we get square root B over square root of A, correct? So which is definitely equals to minus square root of B over A, right? So that is how you should prove this particular equation. You should solve this particular question. I hope that helps. Thank you and all the best.